In today's video, I'd like to talk about gated recurrent unit, abbreviated as GRU. And before I talk about it, let me train the model, because my code hasn't really been optimized yet, so it takes quite a while to train the model. So what is GRU? It's advanced version of LSTM. Like LSTM, it has created so that it solves the vanishing and exploding gradients. Those happen when gradients are either getting too small or too big, since when you compute gradients in recurrent neural networks, since the weights are shared across all the states. Let me see if I could find the it's like this. This arrow contains weights for hidden to hidden, and when you have to compute gradients for this weights, you have to backpropagate number of time steps. So if the time steps was 10, you'd have to backpropagate 10 times, and you'd have to do this number of epochs. So especially if you're using hyperbolic tangent, the gradients becomes really small, and which means the loss wouldn't even decrease, because the gradients are so small. You wouldn't even try to decrease the loss. So same as before, I use the Apple stock price data set. I do normalization, splitting into train and test, and create sequences, and I call it the GRU class. Which initialize the parameters I use, the parameters used for the model. In GRU, it has fewer parameters than LSTM, because in LSTM it has 3 gates input. Forget what is it? Yeah, it has 3 gates, so each gate has each parameters, and also this cell states, this doesn't exist in GRU. So essentially, when you train the model using GRU, most likely faster to train. And after initializing the model, the class, I call train function, which is this one. First, I call the forward function, which does forward propagation. So up to here, it's almost same and this is the forward propagation, where forward propagation happens. So this is the update gate, and this is the reset gate. And this is the candidate. This is called candidate hat. So what this forward propagation does is that you see this sigmoid function which generates values between 0 and 1. So if this zt was, let's say, 1, and if you subtract 1 from 1, it becomes 0 and multiply by previous hidden states. So this entire equation becomes 0, which means in this time step, the model has decided not to keep the previous. The model thought previous hidden state is not that important. It thinks previous hidden states shouldn't be kept for this time step. But if this was like 0, 1 minus 0 becomes 1, and 1 times previous hidden states means previous hidden states, so previous hidden states stays. And same goes for reset gates. This decides how much. So if this was 1, it means previous hidden states should be kept. But if it was 0, this whole equation becomes 0. And when this comes here, only x, the model thinks the input x should be kept. So, and this thing is called candidate, and this is multiplied by this zt. So it's essentially like switch. And yeah, it looks like this. And after the forward function, this is all back propagation. And again, I had to use add-in optimizer. So yeah, this is all back propagation, and this is the equation for back propagation. And one thing I had to do some chain rules, but yeah, it's quite complicated, so yeah, and that's it. And I just call evaluate and predict function. And this is the test loss. And the numbers on the left is the true values, and on the right is what model has predicted. So more or less the values are, it kind of close, right? I don't have TensorFlow example code this time, so I don't have stuff, I don't have things to compare. But if you write similar code in TensorFlow, probably the result would look like this, I assume. So in my opinion, it's faster than LSTM, definitely, because it has fewer parameters and fewer gates. And there's some optimization I could do, like this is hyperbolic. I could just here I could just write candidate. I mean, this might be too technical, but yeah, it just I have things I could optimize more, but I haven't really done it. So I think this is it for today's video, and in a few days I'll be working on bi-directional GRU. So yeah, if I finish implementing that, maybe I'll be making a video for that. So thank you.